Hey everybody, welcome back. This is Mr. Schultz. We're taking a look at 722 today. 722, so let's get started. It says this, so our general equation that we wrote last time, a times by sine of x minus h plus, and then close that parentheses, plus k. Does that allow for every possible transformation? Hint, hint, no. So there's some other transformations that happen here, and so we wanted to be able to do other transformations than what we've seen in kind of these that we've used in kind of x squareds or exponentials or things like that. So let's take a look at what some of those other ones are. So we're going to take a look at this problem, which says that Brianna is an air traffic controller. Every day she watches the radar line that goes around in circles here. Go around on a particularly slow travel day. Brianna knows it takes 2 seconds for the radar line to travel through the angle of pi 6 radians. So it's taking about 2 seconds to go about 30 degrees there. She decided to make a graph in which the input is time and the output is the distance from the outward end of the radar line to the horizontal axis. So basically that kind of radian or degree measurement there. So your task, following the input and output specifications above, make a table and graph for Brianna's radar. So let's take a look at that here. All right, so here we go. So the input is time. So we know that at 0 seconds, it's gone 0. So at 2 seconds, it's gone that pi over 6. At 4 seconds, it's gone that pi over 3. That'd be 2 over 6, 3 over 6, 4 over 6. These are just a bunch of reduced fractions here. So this would be what? Pi over 2. This would be 2 pi over 3. This would be 5 pi over 6. And this would be, of course, just normal pi. And we're just counting up our seconds. So 6, 8, 10, and 12. So there's our table there based off of that. And again, the input is that time and the output is basically the radians or the distance. Next up, we want to make a graph of this. So let's take a look at that. So what we're expecting here is that as we've got this, we've got 2, 4, 6, 8, 10, and 12 seconds. This is my x-axis. We would kind of expect this thing to be doing something like this. But notice what it's doing. It's actually doing just this super long, slow, gradual rise up to pi there. Then eventually it's going to come back down. Well, that length there is just really different. This is because just pi, well, that's 3.14. That'd be like right here. So clearly we have stretched out or kind of pulled apart the graph so that it's not going quite as fast. It's been stretched out so that it's a much longer piece there, and I'll get to what that word is here on the next screen. So that word that I should have just said was cycle. So the cycle length is just basically how long it takes to go through one of its progressions there. So if I move like that, versus if I have something that's stretched out much longer and it's taking much longer to get through that cycle there. So it is possible to kind of stretch that out. So we want to figure out, how do we add a parameter that will cause this sine cycle to stretch out? How can we do that? So using your graphing calculator, test the result of putting a new parameter into your general equation, and let's see what happens. I think this is a great thing to do on Desmos, because you just kind of just put some sort of a letter in there. Maybe we'll call it B or something like that. And we'll just try to figure out what parameter causes it to change there. And yeah, and so this is a great thing to do. But instead of just randomly, okay, am I going to put a B here? Am I going to put a B here? Am I going to put a B here? Like just kind of randomly like diving and hoping that you find it. Let's think about what we are doing. We are stretching out the actual function itself. So we are not stretching it out here, but we're trying to actually modify our x values and stretch them out here. So when I think about modifying the x value, but not like totally modifying it, because that's what this is doing. That's just moving it like left or right. We want to modify the x value before it hits our operation, which our operation in this case is sine. So what I'm looking for is, I'm going to end up with something that looks like this: a sine of b times by x minus h, because that's going to end up kind of lengthening that piece out here. Let's see, which this is kind of this third part here. Let's just see what that looks like on Desmos here. Okay, so let me show you a couple of things here. One, just some sort of formatting things so that I could get the slider on Desmos. I couldn't do it like this, like let's place that B in there, and that's because I need that X thing to happen kind of independently. So notice that I have to kind of in this green one that I have to have that B kind of outside of the X operation, and then notice as I increase that B, it's actually making the cycles go faster as I lengthen it out. Now we're getting closer to that radar screen here. And notice that once I get down to negatives, hey, it's that thing we found before where I'm actually kind of taking the inverse of, and I've kind of mirrored it there. So what I'm looking for, if I'm going to get something that's going to lengthen out, I'm looking for numbers that are between 0 and 1. That's going to kind of lengthen it out there. And as I get higher than that, then it's going to shrink it up and kind of push it together from there. So our generalized form there then is going to be just exactly like we talked about right up here. I'm going to write it one more time. Y equals 8, that's that vertical. Sine of B times by x minus h, that's that horizontal movement, plus k. You can think about that as being your B value or your Y. That's your shift. We'll call it up and down. And then B, this is that cycle function there that that is happening there. We also use this word period to describe that, which you will see on the next slide here. All right, so here it is, that cycle length. The math word there is period. So which of the following have a period of 2 pi, which do not? How can you tell if the period's not 2 pi, then what is it? Basically, how long does it take to go through one rotation? So here, this one does not have a cycle length of 2 pi. It's a cycle length of pi. It just takes one time to get through there. It would take a second rotation there to get to that 2 pi spot. A pendulum takes 3 seconds. Well, remember that 2 pi, that would be the equivalent of 6.28 approximately. So obviously 3 seconds is not 6.28 seconds, so this one does not. The cycle is 3 seconds. The cycle or period is 3 seconds. This is just our standard form here. So our standard form is going to have that cycle length, yes, of 2 pi. Radar line takes 1 second to travel through 1 radian. So it's going to take it 6.28 seconds to go through 6.28 radians, which is pi and pi. So yes, this one also has a period of 2 pi. All right, that's kind of everything that we have got for today. So be sure to check out the review and preview, and I'll see you next time.